In this video, we're going to discuss a wave traveling through a string. So let's talk a little bit about string instruments first. If you've ever played a string instrument, you're aware of if you break a string and you go to replace it, that you can't just pick any old string up, that you need to get a specific string for the specific position on the guitar. And if you've ever looked at different types of string instruments, if you look at a bass string compared to a violin strings are much thinner and shorter, and bass strings are much wider and longer. So there's a difference between the sound that is made by the instrument based upon the type of string that you are plucking and sending a wave through. Also, when you go to tune a string instrument, you'll see them adjusting the screws at the end to adjust the tension in the string. Tension also has an effect on how the wave travels through that particular string. So when we calculate the speed of a wave on a string, we find that that speed is equal to the square root of the tension in the string divided by the linear mass density. So F of t is tension. Mu here is the linear mass density. And mu is going to equal the mass divided by length of the string. So we see here the observation we make in real life between different string instruments and how the people playing the string instruments engage with that string instrument equates to the equation that we have written down here. The next video I'm going to have linked in the list is a video of a person who put their iPhone inside of their guitar and started playing. And you can see how each string is different and how the waves in each string are slightly different.